Okay, we're going to talk about polygons and the angles of vertices of polygons. So let me tell you what a polygon is. And a polygon is a closed shape, and it's made from non-intersecting line segments. So here's 3 examples of polygons. You can see we have a bunch of line segments that are joined up at their end points and only their end points. And it's closed, so it's bounded by that intersection of the endpoints of line segments. This one has 1, 2, 3, 4, 5, 6 sides, so this is a hexagon, and the names for all of the different types of polygons are here, depending on the number of sides. And in general, you can just call them n-gon. So if we were talking about a polygon with 14 sides, you can just call it a 14-gon, and that is fine. Here we have a triangle that has 3 sides, and I drew this one kind of small, but this is an octagon. It has 8 sides, so they're examples of polygons. And some non-examples are these 3. Let me show you why. This one is made up of non-intersecting line segments, but it's not closed. There's no kind of clear interior or exterior of this. So this is not closed, so it's not a polygon. This one has the diagonal line segments intersecting at the middle there. So that is not a polygon since these diagonal line segments intersect. And the last one here, this isn't a polygon since it's closed and nothing intersects, but this bit here isn't a line segment, it's a curved line. So you can't have a curve in a polygon, so that's not a polygon either. Okay, so in particular, we can describe triangles in 2 ways. We can classify them either by their angles or by the length of sides. And I'm sure you've heard of these before, so let's just make sure we understand what these words mean. So if we have an acute triangle has all the angles in the triangle being less than 90 degrees. So here's an example of an acute triangle. Remember, this is a 90-degree angle up here, and you can see that all 3 angles of our triangle are less open than a 90-degree angle. A right triangle has exactly 1 angle, that is 90 degrees. And an obtuse triangle has 1 angle that's larger than 90 degrees. That's more open than a right angle. So in this triangle, here is our angle that's larger than 90 degrees. It's more open than a 90-degree angle. So that's classifying our triangles by angles. And we can classify them by lengths of sides as well, and congruent sides. So an equilateral triangle, that's a triangle where all the sides are congruent. So all 3 sides, let me try and draw this, have the same length. And because this is just a sketch and I want you guys to see that for sure, I'm going to put little tick markings to say that those sides are congruent. Isosceles triangles have exactly 2 congruent sides. So something that looks like that, and the other side is not congruent to the other 2. And a scalene triangle, well, that just has no congruent sides. So you can't have 1 congruent side. A congruence happens in at least pairs. So it doesn't make sense to talk about 1 congruent side, so you have no congruent side. So every side has a different length. There's an example of a scalene triangle. And later on, we'll show that equilateral triangles, not only do they have 3 congruent sides, but they have 3 congruent angles. Isosceles triangles they have two congruent sides and they have two congruent angles. And scalene triangle have no congruent sides and no congruent angles. And we'll show that when we get into triangles a little bit later in the course. So here's a question that I think most people know the answer to. What is the sum of the measures of the angles in a triangle? If I take the measures, let me draw just a random triangle here. If I take the measures of these three angles and I add them together, what do I get? And I think most people know from their schooling days that the sum of the angles of a triangle is 180 degrees. But that's just a fact. The question is, why is that fact true? How do we know this? So that's what we're going to talk about now, how we can show that a triangle has 180 degrees. And then using that fact, we'll be able to show that any polygon has a multiple of 180 degrees as the sum of the measures of the angles. So this is going to be our starting place. So let me kind of show you why this is the case. This is just a little proof of this result. So let's draw a triangle here. Here's my triangle. That'll do. It can be any old triangle that we like. And I'm going to label this A, B, and C. So we have angle A, angle B, and angle C. All right. What I'm going to do now is take my triangle, pick a side, it doesn't matter which one. So I'll pick the side AB here. I'll pick this side. And I want to draw a line parallel to the line segment AB through the point C. So let me do that. I'll draw this in green, and I'll just do my best here. Again, this is only a sketch. So I'll put some parallel markings in there to kind of indicate this. Maybe I'll use blue. So those lines are parallel. Okay. So if we think about this, this looks a lot like the situation of transversal of parallel lines. We can think of extending line segment AC and line segment BC into lines, and then it looks almost identical. In fact, it does look identical to a transversal of parallel lines situation. So let me extend these line segments to lines. I'll just extend all of them, and then we'll talk about what's going on here. And this one. There we go. All right. Now let's move some of these angles around using our parallel X rule to kind of help us out here. So we have this angle here in, I'll mark it like this. Angle A will be in red. That's that guy. Angle B will be in blue. That's that guy. And angle C will be in yellow. That's that guy. And I want to show that the sum of those is 180 degrees. So let's consider each of these line segments AC and BC separately in this diagram, so we can use a transversal parallel lines. So let me scroll to make myself a little bit more room here. So along with the parallel lines, consider, let's say, line AC. So just to see what's going on here, I'm going to sketch what I mean. So we're just going to erase this guy in our minds. We're just not even going to think that that is there. So we're thinking of the diagram above without line BC in it for now. So it looks something like this. So you can really see the transversal of parallel lines. Okay. So we can say right away, by the transversal of parallel lines, I know that A in my diagram, which is this guy, that is congruent to this guy just by the regular x rule. And then by the parallel x rule, it corresponds to this angle. So, by the x rule and parallel x rule, we have that, I'll just mark this in the diagram here. I'll call this angle, I don't know, S, I guess. So this will be angle S. And I know that angle S is congruent to angle A. So S, angle S, is congruent to angle A. Okay. So let's do the same thing now, except with line segment BC. So we'll erase AC from the diagram in our minds. So now consider, along with the parallel lines, consider line BC. So in our diagram, we're erasing this line, so we're thinking of it looking something like this now. And again, this is a transversal of parallel lines. We're going to play the same game. We know this is angle B. So by the x rule, that angle is congruent to it. Let me make this a little bit better. And by the parallel x rule, I can move that angle up there. So I'll call this angle T, I guess. And by the parallel x rule and the x rule, T is congruent to B. So by the x rule and the parallel x rule, angle T, maybe use a capital T since the other one is capital. So this will be capital T. So this will be capital T is congruent to angle B. Okay. Now look, we have these three angles here, S, C, and T. And all of these break up a straight line. They break up this straight parallel line that we added. So they're supplementary. So since angles S, C, and T break up the added parallel line, we know they're supplementary. These angles are supplementary. So that means that the measure of angle S plus the measure of angle C plus the measure of angle T is 180 degrees. So we're almost there. So remember that S is congruent to A and T is congruent to B. Congruent means they have the same measure. So we just have to write that down and we have what we need. But since let's say the measure of S equals the measure of A, since they're congruent, and the measure of T equals the measure of B, we have that the measure of A plus the measure of C plus the measure of B equals 180 degrees. So the sum of the measures of the angles in our triangle, A, B, and C, equals 180 degrees. And again, all we did was use our parallel X rule. We just drew a parallel line through C, parallel to the other side that doesn't contain C. And we used our parallel X rule to move some angles up here. Realized these guys are supplementary, so they must add to 180 degrees. But hey, S and A are congruent, and B and T are congruent. So we know that the measure of A plus the measure of B plus the measure of C is 180 degrees.